great to see you. I will admit, I am kind of worn out. These guys were rough. They told me they were going to have a few questions along with the stuff that I would talk about a week before. Did you start actually sending me a Google Doc with the questions? That's a great group. I really appreciate it. I also enjoy being here in town. I was hoping to take in a game of ball game while I was here, but it rained yesterday. I'm big on minor league teams, so I had never been inside this stadium before, and now this is my last chance. I don't think I'll be back before the new stadium next year, but I'll definitely be back next year. Yeah. I live in Kentucky, and I almost said I live in Kentucky in the United States. You know where the United States is. So I drove here, which was actually also fantastic. I fly a lot, but this time I got to do the Blue Ridge Parkway and tried everything. I had to have a lot of self-control to not turn off on the Bourbon Trail and down, but I had a good time. Okay, so what I wanted to talk about is this idea of creating an API that can change over time safely without hurting anybody. As we do more and more APIs, suddenly it becomes more important for them to last a long time without causing things to break. And how many people are primarily front-end types, developer types? Consumers, right? How many people are more for the back-end types, right? So I did a talk earlier this year at OSCON, at QCon, and it was called Clients Matter, Services Don't. It's sort of a trolling message about the way clients have been sort of driving the kinds of interfaces that our companies that I work with are creating. More and more client developers are sort of leading the charge as to what needs to be built and how it needs to be built and how it needs to be usable and so on and so forth. So that sort of sparks more talk about something called evolvable, something called services that are adaptive. And that's sort of where this talk comes from. This is a version of a talk I did at the Open Source Conference a few weeks ago. I'll be so disappointed. Give me a second. I know. Am I just looking for trouble? Let's get the light out there. This would be really boring if I had to stay up. Wow. Okay. Okay, so there's something coming with that. Okay, I had it stopped. All right, so just a little bit about myself. This is me. Mammond is my handle in GitHub and Twitter and LinkedIn and just about any other social media source. So that's how you can find me. If I don't get a chance to talk with you today, please connect with me on some social media. I'd love to talk more about what we're talking about today. You'll notice I've got this little avatar. This is a thing I've had for years and years. I love this avatar because it looks so much better than real me, but everybody remembers that. So that's good. I'm really lucky to be involved with O'Reilly Media. So 3 years ago, I created a book called Hypermedia APIs, which is a very, very narrow book, very focused on this one idea, using hypermedia as a way to create business APIs. I worked with Leonard Richardson. Does anybody know Leonard Richardson's maturity model, Leonard Richardson's RESTful web services book? Basically, the create, read, update, delete pattern we do today, that's Leonard. Leonard really documented that really well. Leonard was the technical editor for my hypermedia book, and he said, you know, after reading this, I have to rewrite my book. Thanks to you. So he said, as punishment, you have to help me. He's a great writer. This is a really fun book. It's a much bigger book. It's like 4 or 5 pages, but it's a really good read. And then recently, I did a video series for O'Reilly. See that face? See that? You want to trust your kids to that? So that's why I use the avatar. Right? That doesn't make sense. I work for a company called CA Technologies, and we're in a group called the API Academy. I mention this simply because these are some really, really smart people. I'm so proud to be a part of this group. It's sort of a think tank or a thought group about APIs in general, and There's Ronnie Mitra in London, Holger Reinhardt in Stuttgart, Germany, Irakli Nadarashvili, who created the NPR APIs, is based in Philly, Matt McCarty in Vancouver. It's a really, really great group. And we have this website that has this really funky URL, apiacademy.co. And there's lots of cool stuff on that site. So I just encourage you to go there. I'll warn you, it's definitely a self-promoting place. They'll want to collect all sorts of information from you and tell you all sorts of things we're doing. But there's a lot of good content there, and I'm really proud to be associated with that. All right, so here's the thing. How many people have built a web API so far? Right? How many people have built a web API a year ago? 2 years ago? 3 years ago? Look, we got some good people. How many people never changed that API? Oh, some of you never changed that API. That's smart, actually. That's very good. Because the problem is, over time, we need change happens. Right? In fact, when you start out on the process of creating an API, you're setting yourself up for this maze of all sorts of challenges. Because there's time, right? And time changes us. I will meet you 6 months from now, and you will look at me, and all the cells in my body will change on the screen. Be different, but you won't care, right? Because it'll be me, right? But I've changed in a very tiny way. Change happens all the time. Sometimes I may have changed in a major way. Maybe I've lost my hair by then. Hopefully, maybe I've lost a couple of pounds by then. There'll be all sorts of things that change who I am, but you'll still kind of recognize me. The problem is, most of us who build APIs, we can't bridge that gap. Smallest things change. All of a sudden, none of the client applications work. Right? You can't bridge that gap. You can't recognize the general shape of things. We only recognize the very specific nature. So that's really the challenge. When you set out to create an API and invite a bunch of clients to use it, you're setting out on this sort of adventure through this process. Change is also constant. Every day something changes. Somebody comes up with a better way to solve a problem, a faster way to do it, an extra argument we need, another function we need. All these things will cause a change. One of the things we can do is leave it behind and never mess with it again, and maybe go build another building next door and tell everybody to move out and go move in this one. Or we can figure out how we can reuse that room, reuse that building, do some new things with it. So that's really what this is about, this idea of this challenging. And the way we usually think we approach this problem of change over time is this technique. Now, sometimes we confuse this technique with change. Right? We think, oh, we have to version it. That means we think we have to change it. Actually, what we mean is we've changed it, so we need to use some technique to sort it out. Versioning is the most common way you can have it on the web. So there are a lot of possible ways to approach this idea of change on the web. The one is called monolith versioning. It used to be version 1. It's now version 2. Anybody that's using version 1 is out of luck. Go to 2. Go to 3. Go to 4. And we sort of orchestrate it so, like we say, well, we're in version 1, so we're going to put a beta of version 2 to give you all a chance to move over, right? Test it out a little bit. And then suddenly we're going to deprecate 1. We won't kill it, but now it's really called 2, right? So everybody should be doing 2. You laggards have just a couple more months to start it up again. And then we're going to create a new beta, we're going to call it version 3, right? And then there's still 1 and there's still 2. But what we're going to do is eventually we'll make version 3 the thing and we'll deprecate 2, and I'm sorry, we're going to kill it. Right? We could have, so they can sort of march along, right? So you have this monolithic view where everybody needs to be basically on the same. So who does this? Dropbox. Dropbox does this. It's a pretty simple system. Basically, they deprecate a version after a year. That's their promise. Who uses Linux? Anybody use Linux? Right. So we know this idea about the April on the even years. Is that the deal? That gets 5 years support. Right. The other ones are all temporary. Right. But I'll keep this one for 5 years. That's sort of the notion of versioning. That's how Linux solves that problem. Their their 04 version is always the even years is always going to be. So Dropbox does this. There's another versioning though. It's called side-by-side, which a lot of us do. And the side-by-side versioning is I'll just create another one. I'll support that. And then I'll create another one. And I'll support all 3. Create another one, support all 4. And you keep going, and keep going, and keep going. So what happens is you get some customers that came in on version 1 and they never change. You can never get them to move. I have a customer that's on version 7 and they have that sort of rule about 1, 2, 3. Their biggest revenue generated customers on version 1. So they got to maintain it. So who does this? Salesforce. Anybody work with Salesforce? Salesforce. Every 4 months, I think. Every 4 months, new version. Anybody have an idea how many versions they're currently supporting in parallel? Found out. 24. I couldn't believe it when I talked. Seriously, 24? You do 24 builds? 24 tests? Right? 24 deployments? But yeah, we just leave it. I said, well, are they back in compatible? No, we don't know. It's just new. And you can stay on, we have people on version 1. I guess if you're that big, right? I mean, these people know what they're doing, right? They've been at this a while, right? Every 120 days. Okay. Yeah, 20 plus is their parallel version strategy. So another one is backward compatible. So I'll make changes, but I'll make sure that the changes I make in this new version don't undo anything from the old version. So you can safely just keep moving up, moving up, moving up. All that stuff that we used to do 10 years ago, we're still doing, but there's lots of other cool stuff. So they keep moving and keep moving and keep moving. So that's sort of the backward compatible approach. Who does that? PayPal. PayPal has a commitment to no breaking changes. Another company that has a commitment to this is GitHub. GitHub says any new API or any change we make to our new API is not going to break any existing. That's harder. That's actually harder to do, right? Because you have to kind of like carry all the baggage. Right? Anybody use Microsoft Word ever? What version are we on? Does anybody know? They stopped numbering it, so it's hard. It's about 10 or 11 or something like that. Do you know that Word 1.0 still works? You can still load a 1.0 document into 11 because 11 is backward compatible. That's a huge baggage. That's almost 20 years of Word docs. It's pretty good. That's hard to do. But the thing is, that word version, right? Version actually is from a root word change, to verge, to turn, to change, and to turn around, and actually to diverge. And a lot of times that's not what you need to do. You don't need to tell people, I'm going to turn this all around. There's another way to think about it. And that backward compatible story that we talked about a minute ago, there's actually another way to think about that, or another way to talk about that. And that is extensions, or stretching. I'm going to extend the interface. I'm going to add new things to it. I'm going to build on top of what I have and keep adding more. So backward compatibility is essentially creating extensions to your current API. Now those of us who are architects, especially server side, we don't like this too much. Because what we want to do is sort of get rid of the evidence, right? We want to bury those bad ideas. One person explained to me once, it's called, I want to go Soviet on everything. Right? Like, that doesn't exist, it's been erased from history. That person never exists. I got a lot of APIs like that. I really wish were not around as evidence. Some of them are 20 years old. And it's like, oh, really? Did we do that? But people are using it. I can't get rid of it. There's all sorts of other examples of extension in complex systems, like your appendix, tonsils, your little toe, your lizard brain. It really is way too complicated to yank these suckers out. Just leave them in, and occasionally they cause some problems. They're really not needed. It's kind of hard to explain to someone why you got a lizard brain. But just trust me, it's there. And when you create a system where lots of independent parts work, where you can't control all of the customers, all the clients, all the bits and pieces, a lot of times it's better just to leave it in, just to leave it alone, just keep extending what you have. So that's really sort of the future. That's really sort of the scary message involved in all this kind of stuff. And that is, how do you actually do this? So if extensions are really the secret, then how do you go about creating API extensions safely that don't screw things up? One of the things, I work in a lot of organizations where what they're trying to do is make it relatively easy for people in the company to be creative and come up with new things, but relatively hard for them to screw up. Isn't that nice? That's what we want, right? I want it easy for me to be creative and hard for me to hurt the rest of the group, right? So what does that mean? How do you do that? So I want to talk about two main ways of dealing with extensions for existing APIs in a way that's safe and hard to mess up. So one is I want to talk about the messages we send back and forth. How you can make changes to the messages you send without hurting the clients that receive them. And the other one is I want to talk about the code behind it on the server side. I'm still going to talk a lot about the server side, but I'll also talk about client side. So how can I write code? How can I code defensively? How can I code optimistically? How can I code for the future on both client and server in this case? So I'm going to talk about the message, and then I'm going to talk about both ends. Right? So let's talk about message design first. So one of the biggest things that I see happening now over and over again is the notion of extending the message object. I decided to do this in JSON today, but it'll be an XML or YAML or HTML. So this is a pretty typical object that we might pass around between parties. We've told the clients that they have to memorize all the names of things like given name and family name and URL and email and stuff like that. But it turns out that we want to create additional information without screwing up people who are already there. So very often what happens is we create an extra bucket at the end called the extension or the property bag or something else like this. And if you design this in the first day, and you say, look, you're going to get all these name things and then some other stuff, clients already can be prepared for this. When the other stuff appears, it's not a disaster. If I'm doing schema validation, making sure that I have the right properties in the right order and all that, adding this extra step at the end won't break my schema validation. It'll say, yeah, I've got this and this and this and this, and then stop. Right? So I'm actually sort of like slipping that stuff in. And what you do typically in these extender patterns is it's a name-value pair. Like the name of this thing is this and the value is that. Those of us who wrote code API interfaces often slipped in an extra function that ended in the letters EX. So it was user services extended. And it usually took an object as arguments. And we would just throw whatever arguments we needed in there, and maybe there was like a sort of an execution name and an object bucket. And we could extend that interface and not break any implementation details. At Microsoft, that's commonly the operating system, because they would have this sort of extended function. So on the wire, we can do the same thing. We start adding this up. I worked in the company that used a pattern like this for a long time, and they also had a really cool strategy as they began to version things in the future. They would say if everybody really wanted this workflow thing, eventually we could pluck it out of extended and move it up into the major object space. And we could advertise that change over time and make people aware of it. But this idea of extending and putting things at the end is really valuable, it's really important, and it's very easy to do. And if you do it in this way, rather than actually just saying you could have any number of arguments, but just putting it in this bag, you can actually clients can still do some strong validation schema patterns. And they can do it in whether it's a JSON schema or XSD. So extending messages lets you add backward compatible changes. I can't change what's there, right? I couldn't change what URL was or what family name was, but I could add more to it. So another big challenge is not just adding additional features, but changing the structure of the message. So here's a case where I've got some information, like the ID and URL, and then I have a person, then I have an address. Right? So I've actually put structure into the message. And that structure is sort of a nesting pattern. As soon as you start creating these nesting and hierarchies, you're really increasing the likelihood that something will break, that you'll have to break something later. What happens if I come up with an array of addresses? I need another address, right? So what I'm going to do is sort of do it address 2 or address 3, but it just gets bigger and bigger. But I'd love to be able to do an array if I could. The problem is that's going to break things, right? So by introducing structure, I really introduce a real challenge for the future. Very often I'll see people do this instead. They'll flatten out the structure. It turns out on the wire, structure doesn't matter. It matters in your code. It's really important in your code. You need an object model, you need an object graph. But on the wire, it really doesn't matter. What I've also seen people do, I'm not sure if I have an example of that here. No, I don't. Is actually create an additional property that goes along with this. So it might, like this item, this item, this item, this item, this item, might have an extra property called address. In XML, it's really easy. You just create an attribute. In JSON, you would maybe create these as anonymous objects. So then you could actually say, hey, all those things that say address, put those in this object on the client side. All those things that say phone number, or all those things that say person, or something like that. So flattening this out is actually much smarter for message passing. It's a disaster for code, but the message is not code. For us, we have our own code, and we can sort of do it. So the focus on passing the data, not the structure, gives you the chance to change things more easily. And then you're not so worried that the visual of that message doesn't match the mental model of the application. Right? So there are lots of ways to in real life where we see examples of this, where what happens is we tack things onto a package or something. We just tape things together and hand it off to somebody, and they sort of take it apart. Or we have a folder, we just stick lots of things in the folder and hand it to somebody. That's not how the business looks, but we can operate by carrying this folder. So focus on passing data and not structure. Okay. So there are also some other ways that we can approach this problem. So what I've really talked about are two things. Ways that you can extend an object and ways that you can rearrange the message. It turns out there have been people working on this for a little while. There are several new formats that are specifically designed to make it easy to pass data on the wire and make it independent of any object model on either the server or the client. So it's easy to serialize in and out. The most popular one today is one that's called HAP, Hypermedia Application Language. You use HAP, right? Yes. So yeah, the Foxy card system. Has anybody else ever seen HAL before? You guys use HAL? Somebody seen it? So this actually has a set of structure to it. It says there's a link collection or a link object that starts with underscore links. There's an embedded object that starts with underscore embedded, so we can have sort of a little bit of nesting here. And there's a standard way that this is shaped. There's another one called collection JSON, which is a little similar, but it's much more restricted. It's actually designed for lists of things. It's not really designed for a free form like how you can actually use a sort of an object and custom object. And collection JSON wants you to just do name value comparison. There's another one called Siren, which I think you guys are working with a little bit here on the planet, right? And Siren actually has this idea of properties and entities and links and templates and some other things. I sort of refer to Siren as the HTML or curly braces. Almost all of the features and more of an unstructured document, but enough structure to actually be able to find out where all the links are, where all the properties are. I picked another version. I actually switched to XML because I was just kind of bored with curly braces. This is a format I've been working on for the last 6 months or so. It's actually still very, very new. But in Uber, the idea is that everything is a data element. That data element is either a link somewhere or it's actually a piece of data. You can nest them as much. It's a little bit more esoteric, but there are lots. It's actually very easy to add more to this or to actually change one of the items to a link without breaking other things. There are a lot of aspects to that. There's also a thing called JSON API and Ruby people in the room, Ember.js people in the room, right? So this is actually becoming sort of baked into a lot of what Ruby does. And JSON API is owned by Steve Platnick and the Good Cats, like two really, really smart people. And it has a similar thing where it has links and so what's the common theme in the four that I picked out? There's also a thing called Han and Mason and a couple other things. What's that? The links is definitely the common thing in these new designs. But the biggest one is that they're message-oriented, not object. That's a big deal. It's message-oriented, not object. And in fact, it means that whether I write it in Ruby or write it in Scala or Erlang or JavaScript or C# or Java or any of that, I can use the same message format. That's really, really powerful. And it's more than just JSON or XML. It's actually structured. Like Luke was saying, there's some links here, and there's some objects here, and there's some properties here, and there's some templates here. So you sort of know ahead of time. There's an agreement on what we're passing back and forth, what the shape of it is, not what the meaning is. It's kind of another discussion, but that's like a really important one. But I think the idea of message over object is getting more and more powerful and more popular. Roy Fielding, the guy who created the dissertation that creates REST, 2001, has a really good quote about this general space. It's far easier to standardize the representation, the message model, and the relation types, the rel equals and the object, or the property names, than it is to standardize on objects and object-specific interfaces. So this is, what he's really saying is when you've got people all over the world, people you've never met, it's much easier to get them to say, oh, yeah, I understand what HTML is, than to say, oh, I understand your object model. And when you want to get lots of people together and lots of people to work in the same space, and like in an industry, it's really hard to get them to all agree to the same object. But it's easy to get them to agree to HTML, CJ, or HAL. And I think that's the real message of future APIs from a wire side. Focus on message passing rather than object passing. Think about it this way. If I first met you, if we share the same language, whether it's French or English or whatever, we can start having a conversation. We'll have to kind of negotiate a little bit so I understand what you mean by nice and good and all these other value terms, right? Like, well, that's really nice and that's really good and I like this person. I got to figure that out. But we can at least communicate and start communicating. But if, like most of our APIs today, I had to understand your entire object model and vocabulary before we could even say hello, there'd be an awful lot of people I could use. And unfortunately, a lot of times, that's the way our applications work today. You need to first read all of my documentation and understand all of my object model, then make your object model. That's going to be really hard to scale. Okay. What's the most common message passing format on the web today? Query string. Or it turns out not only is this the query string, but this is also data. Yes. Most common format. Why? Why? It is ugly. It is incredibly limited. It's easy. Easy. And it's easy to extend. I put 3 more on, 4 more on, 5 more on. Right? That's the beauty of this. And that's why it still exists today, even 20 years later. There's no structure here, because they don't need it. I'm just passing values. Given name is this, family name is that. We can all use this. We can all make sense of this. And that's a good thing to keep in mind. As a matter of fact, when I designed that new Uber format, the sort of complicated format about nested relationships and everything could be a link, the only message passing format I supported was because it's easy. So message design is important because it affects every one of us. We're all receiving messages, we're all sending it. But it's not the only place. The other spot is how we implement our own code, whether it's on the client side or the server side. And how we implement can also give us a sense of how easy or how difficult it is to actually make changes in the future or evolve this, handle change over time. So I want to talk about just a couple of ideas. The people here at Lonely Planet actually heard a lot of this speech already, so if you guys are bored, you can walk away for 10 minutes, and it'll probably be fine. So there's some basic implementation details on the server side that are really important. The first one is called connectors and components. Components are not connectors. Components are not connectors. It's really an interesting idea. So what do I mean by components? Databases, file system, queues, transactions, source code. This is your magical sauce. This is stuff that's really valuable to you. This is your intellectual property. Nobody else has this. Nobody has your data model. Nobody has your business model. Nobody has your source code. Nobody knows what those transactions are and how they're managed. That's you. That's big money. That's your investment. and that's private. We don't share that. Even when you create an API, you don't just share your database with everybody. Don't mess with your database. What you do is you create this interface that's sort of like a keyhole view. That little bit, I'll let you see the part that's interesting to you. You know, maybe you're working on content management and you're working on payments or something, but I'm not going to show the whole picture to everybody. When you create an API, by the way, who's the first person that signs up for your public API? You. That's good. Your competitor, right? Let me see if I can figure out what their business model is. When I worked for this content management system company, that's exactly what I did. I signed up for every possible content management API I could. And I learned a lot of stuff I shouldn't have learned. Wow, really? They do that? Wow, that's cool to me. But connectors are different. Connectors like web servers and browser agents and proxy servers and shared caches. What are these? Everybody has these. And you can get free ones, right? You can open source versions of all this stuff, web servers and browsers and all that kind of stuff. Because that's all shared technology we all have. There's no advantage here. There's no strategic advantage. There may be some tactical advantages on which browser you use or which code set you use or something like that. That's really kind of small, because this is all commodity. When we start a business, we don't say, all right, the first thing we're going to do is build a web server from scratch. C, I think C. C. We don't do that, right? We say, find one, get a patch or something. Do that, right? We collect all that stuff. Then we focus on that intellectual property. So connectors are public. It's what everybody does. So it's important to keep the two of them separated. It's important not to put your intellectual property and bury it inside a connector. How do I know that's happened? I've been using PHP. I'm going to switch to Node or something, and I have to rewrite all my business rules. I guess all my business rules were in the connector code. Right? I can't just switch technology now, can I? Or I used to be doing everything as XML, and now I'm going to start doing it as JSON. I have to rewrite all of my components. Oh, crap, my components actually know what format I'm sending out to customers. Big mistake. So keeping them separated is a key implementation detail. So if it starts on my components, you know, they know how to compute taxes, or they know how to do content management, or they know how to do travel services. And if somebody wants it in JSON, fine. If they want it in XML, fine. If they want it in HAL, fine. They want all those, I don't care. That's another deal, because those connectors are separate. So here's an implementation stack that we encourage, and I'm seeing this more and more. They're called different things. But you have some kind of storage medium, whether it's on disk or in database, or local or far away, whether it's AWS or CouchDB or SQL or whatever. And then you've got some business level that we all know about, so I know that how to find storage and how to return something and compute something and turn it into something valuable. Here's the new thing, the representer. Then I know how to represent that object model or that object tree or that graph or whatever that bit of information is in some format that the client wants. Just got a request from a client, and they want to know the latest list of popular places to travel in the area, and that client sent me information that said that she'd like it in JSON. Oh, no problem. I'm going to take this object model, hand it off to my representative, who's going to generate a JSON graph for me and send it off. Maybe she said she wants HTML or XML or HAL or collection JSON. Or they asked me for something I never heard of. Oh my gosh, what is that? Well, you look it up. Hey, they just registered a new media type. We didn't realize this. Let's write a new plugin for the representer, so now we can start representing it as HAL. So it becomes cheap to do that. So that's a key implementation point for the future. As new formats or new message styles come into play, I don't have to rewrite components. I don't gain technical debt in that space. I just need to add more to representers. And then I also have routing, of course. I'll always have routing. But, you know, URL routing, let's think about it. HTTP is pretty good, right? How long has it been around? About 20 years, 25 years? What do you figure? Another 10? Another 20? Another half a century? No, I don't think it should change. HTTP forever, right? No. 25 years ago, we didn't know what it was going to be. Matter of fact, when they were starting to do SOAP services, right, they picked HTTP and SMTP and FTP and all these other formats, all these other protocols for SOAP, because they didn't know who was going to win. I don't know what's going to happen 10 years from now, but I'll bet you it's not going to be HTTP all these devices, all these small things, WebSockets, MQTT, CoAP, telehash, all these other formats for small devices, they're not going to be all HTTP. So my routing is also decoupled from the rest of this too. If it turns out I need to route it over web services, fine. So I have a small example here of this sort of the stack pattern. I won't spend too much time on it. But I literally have these sort of internal storage models, how I do storage and components and representations, and then I have definition sets for each one of these different sort of object sets, like dealing with, this is like somebody who wants to schedule a course online, like, you know, sign up for a class or sign up for, you know, a segment or something, or sign up for school in general or teachers. So these are all separate, right? So these internal models and these connectors know how to talk whatever language is interesting, and the internal models know what's interesting on the backside. So, for instance, if I get a router and it says, hey, listen, they're looking for courses, I can route them to the course connector. So yeah, that's the one that deals with courses. It knows what's possible and what's to do with that, or with schedules, or with students, or something like that. And then, when it comes time to actually do something in courses, like I need to send a list, I know that I can actually look at my components, my below-level components, and say, yeah, I'm looking for courses, give me that list of stuff. And I'll turn it into some kind of templates and represent it in some way and push it out the door. So that representer happens at the end, right? So what happens is the component itself knows nothing about how it's going to get represented. In this case, it was always represented as XML. And there's my actual function for doing things. It knows how to load a list from storage, how to add certain editing features based on what you asked for. And then eventually I know how to parse certain things in the low-level file system. But each one of these are totally separate. The file system management, the component system, the representer system, the routing system, they're all separate. And that means that eventually I can just do things like, oh, listen, add the actions to this, or start doing links. This last format step just adds up different pieces of the puzzle. So each of these can turn out to be independently updated. So this last thing, which does this XML format, could be, I could come up with a JSON format, or I can come up with a HAL format, or something else. And that's not going to affect any of these other pieces on the list. Those don't have any information about format. Right? So what I want to do, go the other way. What I want to do is I want to make sure that these things are all kept in the. The other advantage of that, especially as it grows, is I might have a team that's really in charge of the business rules and a team that's in charge of the data services. Well, they need to move at their own pace. Data service is not going to move very quickly. They have a lot of concerns on their hands. I've talked to the person who's head of data, and she said, look, we're not going to make any major changes until we get a chance to test a lot of features. But the people in the business side said, no, we got new functionality we need to add. Well, you can do that on your own. We're not going to rebuild and retest everything. You can rebuild and retest your pieces. So keeping them separate is really important. So that's server side. The goal on the server side is to keep routing, representation, business model, and storage models all independent. So that gives you a chance to keep all those independent. But there are also some strategies on the client that we alluded to a little bit. So it turns out most of us who build client apps today use the create, read, update, delete model, and we memorize URLs. This was actually described by Leonard Richardson in the book RESTful Web Services. It's kind of the way we all think about doing things today. So I came up with a sort of a really simplistic sort of client-side model for this, just so we can sort of look at it. So very often now we do what's called a single-page application, or an SPA container. Right? So maybe I'm doing this little to-do list. I know I'm going to get a list of data that would get filled in here by an AJAX call, and I've got some possible things, searching and adding and listing and stuff like that. So I'm going to build my container, and then I'm going to write code. The first thing I'll do is memorize all the addresses. Or in some cases, maybe I memorize the pattern for an address. Like I'll put a variable in here instead of the URL pattern. So I memorize the addresses. Then I memorize the shape of the object. I know I'm going to get this thing with a bit of ID and a bit of text. It's a real simple thing. So I'll just iterate through this and display that object. And then I know all the actions. So I'll actually write code for every possible action. I read the documentation. I know what they're going to send me. It says I can do some searches, I can do some ads, and I know what arguments I need to pass and all that kind of stuff. It's very cool. So then finally what happens is when I run it, that SPA gets loaded up. So I get this little list of list items, and I can click to delete, and there'll be some event attached to it, and I've got these buttons, and I can click, and it'll sort of take care of itself. It works really, really well. Here is a summary of what my client code looks like for this CRUD model, or this URI-based model. A little bit of initial stuff, a little bit of making a request and processing the answer, and then I know all the possible things. I can list, I can search, I can add, I can complete. And I know how to show the list for some basic things inside and turn on buttons. Don't add any more stuff, or you're going to break the client. Right? Don't change the shape of the list, because you're going to break the client. Right? Don't change the rules about what I pass, because you'll break the client, because I've memorized all that. And that's the way most of us work today. It's very expedient, it's very efficient, looks kind of nice. It's sort of an easy way to say, oh yeah, I understand this. And it assumes that nothing will change. So a better approach is, instead of memorizing those features, memorizing the addresses and the objects and the actions, is to actually bind to the message model, going back to what we talked about in the first section about messages over objects. I'm not going to bind to the objects of this to-do item. I'm going to bind to the message model. So I'm going to do things slightly differently. I'm going to do what's called a kind of a finite state machine. I'm just going to go do the thing over and over, and based on what's changed, I can illustrate things differently. It's very, very easy. I've got the same data thing, but now I didn't memorize all the possible actions. I said, you know what, there'll be a list of actions here. I'll hear about that later. Turns out that administrators might have actions that visitors don't. I don't need to know. I'll just show them whatever you show me. Okay? So then what I do is I actually focus on the message model and not on the object. So now I'm actually looking, while I'm looking for certain things, like is there certain things in the collection, I'm then saying, hey, are there any links that are in this collection as well, and I'm going to render these links. This actually makes this code a little bit more complex to read, because it's actually looking at the message pattern rather than the individual items in it, and it will render them. So it says, oh, if there's links, then I bet you there's a button. There's probably some buttons here. Is there a button? Oh, let me give a button in. What is that button's name, and what does that button say on it? Okay, I can do that, right? Oh, there's one button, fine. 10? Okay. So now when I get the information back, it's going to look very, very similar, but it'll have a few things different. So not only do I have the items that say, hey, you're going to be able to complete something, I actually have information about what address to send and what method to use. And it turns out there's actually a template pattern. There's a data value that I'm going to send to the address using this method. I also know that there are certain buttons, that I know which method those buttons use, and I know which addresses those buttons use. Notice I didn't memorize those addresses, I got them sent to me. Now what happens is my code looks very different. My code says, yeah, there is one place I got to start. I'll memorize that. And it says, I need to show whatever you give me, and I need to make some requests and process any responses. I need to turn on buttons based on the buttons you hand me. That's it. There's no list of functions. There's no search. There's no add. There's no list, there's no complete, because that information is actually sent to you. So if you add a new function, easy. It'll show up. You pass me the arguments, you tell me what arguments I need to pass along, I can render that. It'll be fine. So now I'm binding to the message model rather than the actual data in the model. So if the data model changes, I won't necessarily break. Now it may turn out that there are certain things in here that a server can send that sort of make the client not work, right? The server could break and send the wrong bits or send the wrong data, but that's, you know, that's life. Something might break along the way. That's not what we're trying to prevent. What we're trying to do is limit the amount of memorization that we have with the client so that we can do things in the future, and that is that same message over object pattern. So even on the client, I'm now writing the client as more of a message-oriented client than an object-oriented. Now, these sort of make sense, and they're nice to look in a sort of trivial kind of way, but what are some lessons in real life? And I'm actually going to switch for a minute to HTTP protocol, because HTTP has been around about 20 years, and we have some major lessons to learn from HTTP. Does anybody know what version we're on in HTTP right now? Yes?
1.1.
1.1. So if you're using a Chrome browser and you're talking to Google, what version of HTTP are you using? Speedy. Huh?
2.
2?
Speedy.
Speedy, which is the beta of 2.
Well, it depends on the server.
It does if you're talking to Google, right?
Oh, if you're talking.
Right? If you're on a Chrome and you're talking to Google. Actually, now if you're on Mozilla and you're talking to Google, you also might be talking Speedy as well. It turns out that sometimes if you run through an old CDN device, a classic content delivery network, some of those are only 1.0 compatible. So the actual message you'll get back is 1.0. Key question here, do we care? Yeah. Because they're backward compatible. And it turns out it's a good thing that they're backward compatible because HTTP screwed up a lot in the beginning. And they're not done screwing it up either, but that's another story. So one of the lessons in creating any of these kinds of interfaces is you never get it right the first time. You never get it right the first time. Luke and I were talking about how we're both working on projects where we're not sort of pulling the final trigger, right? Is that proper to say, right? Because it needs to be just a little bit better, a little bit better. And what did you tell me?
There's always going to be complainers.
There's always going to be complainers. You just need to get it out there and do it, right? And then iterate and make it better, right? It's a really good strategy. And that's the strategy for HTTP. When HTTP was first started, this is a document from 09 from 1992. And it turns out that it only supported GET and only supported HTML. That's it. That's the way it's going to work. There was also this feature called isIndex. There were a bunch of other method names and stuff like that. All right? But we turned out, it didn't really work out so well. By the time we get to 1.0, we realized that, yeah, just supporting HTML is not a good idea. We need a thing like accept headers and some other things. And just supporting read-only is not really going to work out really well. We need posts and something like that. But we could do that and still make all of the .09 servers and clients work together because there was extensibility built into the model. We didn't undo stuff, we added to it, right? To the fact that we get to 3.2, 3.2 is actually when we finally get most of the features that we know today as HTML. But there are a bunch of stuff in 3.2 that we don't do today. Anybody do image maps? Loved image maps. We don't do that anymore. Blink tag, right? What was the other one? Marquee. Marquee, right? Here's the thing I love about HTML. HTML was designed specifically to not have an image tag. It wasn't left out. It was designed specifically to not have an image tag. One of the very first popular browsers, the Netscape browser, said, no, there's going to be pictures. We invented a tag. And Tim Berners-Lee was upset. So no, you can just invent tags. Yeah, we can. I guess you can. And it's a good thing, right? Because that's not what it was designed for. But even HTML was extensible, right? So we can add things. They didn't take stuff away. Matter of fact, today, what happens if you put a marquee in? It
works.
It works. It's backward compatible. Don't put a marquee. Every once in a while, somebody does that, right? They sort of create the 1990s GeoCities site. It has all those features, and it still works. Content type header field is a great example. So we said, it's only going to be HTML. So now we had to say, well, we're sending you text, well, we're sending you HTML, well, we're sending you a PNG. So there's a header that says what we're sending you. I could add a header. It's not in this list, but the one I love most, I talked about earlier today, is when they were creating HTTP, they wanted to optimize the message and cut down the extra repeating characters and things like that. So they said, well, you know that thing where you've got like www.amundsen.com, like it's in every message? Don't do that. Just do whack home or whack, so on, so on. So we'll just get rid of the Amundsen.com part altogether. Well, that was back when one IP address was one domain name. Of course, we don't do that anymore. We do multi-homing, right? The same IP address can have lots of host names. So HTTP was blown out of the water. It couldn't even figure out what site it was supposed to go to. So what did they have to do? They added the host header. Oh yeah, that thing we took out? No, we'll put it back. Right? That's the extend. Right? Well, we'll put it in here, put it in the bag, put it in the headers. Right? So now we do that today. Expires was a great one. So caching, we know about caching. Expire this as of this GMT time. Problem was, we discovered early on that HTTP servers didn't share the same clock worldwide. Some people thought it was 3 o'clock, some people thought it was 4 o'clock, some people thought GMT time was off by 5 minutes. What are we going to do? Create a new caching system called ETAGS, or last modified date. Relative caching. We didn't say cache this until GMT time. We said cache this for 30 seconds. I don't care what time. We added to it. We didn't kill the expires header. Matter of fact, 1.0 still uses it. But we added to it. Authorization was great. When they actually designed authorization, very, very smart. They did not say, this is how we authorize use authentication when we're talking with HTTP. They didn't say that. This is how we do it. No. They said, well, there's at least one way to do it, and we're going to make it an extensible way. The first conversation says, you need to authenticate, and these are the various ways I support for authentication. They built it in extensible the very first day, which is great because we finally have OAuth, which now actually uses www authenticate and the authorization headers the way it should. Because people in 1992 thought this through. They didn't know about OAuth, but they made sure that it was possible. Content encoding is a great example. We realized that messages were too big and too complicated. We wanted to compress them somehow, but we made sure the same thing. We didn't just say, this is how you compress HTTP. We said, you can compress HTTP in at least one way. There may be other ways in the future. Right, so they designed this stuff in. Lots of changes to the protocol over the past 15 years. Lots and lots of changes. One of the reasons it's still alive today is that it was built for that extensibility. And because they had a total commitment to make sure it's all backward compatible. Because blink tags still work, expire still works, and all that stuff still works. And if you don't indicate on content type, it'll send HTML. And all those things still work. So I'll pick another Roy quote. Love this quote. You want it to last a few decades. Don't assume too much. Oh, nobody will ever need that. Don't assume that. Don't assume that you know. But do offer that extensibility. So what's the real lesson in all this stuff as I kind of wrap this up? I love this quote from Darwin. I wish my slide was a little better on this. It's not the strongest. It's the one that's most adaptable. The one that can adapt to the changing conditions. That's really what goes on. And that adaptation, by the way, is often very, very tiny little things that add up over time. Small changes over time. They're not big changes all the time. Sometimes they are, but often it's just very, very tiny changes. So we talked about message design ideas. Use that extension pattern. Keep structure in messages low. Keep them relatively flat. Structure is not important in the message. It's important in the code. Consider new media types that we talked about, Hal and Jason and Mason and Siren and all those other ones. Form UL encoded is still a winner. Whether it's on the query string or in the body, it's still a winner. And everybody knows that in every software, every bit of software, every client-side bit of software, every server-side bit of software knows exactly how to do it. You don't have to invent new code for any of that. And commit to no breaking changes. Even in your very first iteration, just commit to saying, look, I'm not going to break this. It's not that hard. It's more of an attitude than it is a skill. You just have to say, no, I'm sorry. It makes you think twice before you do something. Like, well, geez, I'm going to have to support this for 20 years. Let me think about this. But it's not that big a deal. When you're doing servers, keep components and connectors apart so you can plug and play them. Use representers. Move that whole thing about what the message actually looks like way, way, way away from you. Make sure your business and your storage and your representers can all move asynchronously. This is especially true in a very large organization because you want to make it possible for people to move without waiting around. We all know that experience, right? Well, I'd love to put my changes in, but I gotta wait until Sally. She's holding up the whole thing. She's got this whole business model thing that we all have to wait for. Try to figure out how you can prevent that from happening so your team can keep going. In client implementations, bind to messages, not objects. The object model is going to change a lot. The possible actions are going to change a lot. That message model won't change hardly anything. You can commit to that. Code defensively. Don't assume. Be prepared. Oh, we talked about this a little bit earlier today. You look up at the sky, right, at a distance, and you see a star. You see it's a beautiful star. Turns out, maybe that star's dead by now. By the time the light got to you, right? Just the way the universe works, right? It's a long distance. You go to a web service that's halfway around the world, and you say, "Do you have this code in stock?" And it answers back, "Yes." And by the time you get that message, maybe that code's gone. Somebody else bought it. Code defensively. Because they're messages, and there's time and stuff, right? And make sure that you can convert messages into internal objects as needed. So this whole thing about like the messages are flat doesn't mean your object model is flat internally, right? You can turn that into any object model. So creating these representers, even on the client side, that turn that into that rich object model that we know we can operate on is a real key. And the lessons from HTTP. You won't get it right the first time. Build support for extensions in. If you need to change it once, you might have to change it a lot. So build that sort of feature in. Authentication and content negotiation and all those other things really turn out to be that. It's sort of the, what's the phrase? Yagni? You ain't going to need it, right? Like, don't overbuild. It's sort of the opposite of that story, right? And it's like refactoring. If I create an object and I use it once, that's fine. If I use the same thing twice or the same code twice, maybe I should really think about refactoring these things. If I use it 3 times, well, there's a factor, right? So it's sort of that same thing in a protocol. So change is inevitable. Change is constant. That's actually the good news, because that keeps us all busy, keeps us all working, right? But we can use that to our advantage. And we can get a lot of life and a lot of possibilities out of the existing code that we have without having to rewrite or start from zero. That's what I got. Yeah, I'd love to, if anyone wants to talk about it, it doesn't have to necessarily be this. I'd be happy to answer any questions. Pardon me while I ask somebody to look. Okay.
Maybe it's just me, but I'm kind of curious for a little bit more depth on why to keep the message flat. Like what the dangers are that you're avoiding by doing so.
The biggest danger is that, so the nests are basically containers, like these are all users, or these are all addresses, or these are all products, right? And the biggest danger is that the containerism will change, not the properties, but what belongs in the container. And if I'm using sort of close schema validation on the client, I'll get upset, like my client will start to reject messages. That's really the only danger. There's no danger in actually adding an indent or adding the curly. It's that sort of semantic meaning over time might start to change, so it's more detail on the wire instead of on the client and the server. And that's the only danger. If it turns out that you're actually working in objects that have been around for years already and are not likely to change, the danger is going to be incredibly low. But if you don't know, that sort of don't assume pattern is really good. Right? That's really good. Does that make sense? Yeah. This is totally a sort of design value judgment. There's no sort of hard and fast pattern. That's the only real danger. Yes.
On that, the message versus structure, a lot of the stuff you talked about seems to have a philosophy behind it, and I was wondering if there's, this is a two-part question. I was wondering if there's any...
You're not setting me up, are you? Because we're working.
Is there anything you've read?
You are.
Yeah, there you go. I don't know, if there's what you've learned over time, best practices, I even saw in your code, you're doing certain consistent things that aren't easily breakable. And if there's anything that on a philosophy or even pragmatic programmer sort of level that was influential to you?
I guess a little bit. We talked about this earlier, right? Right. I think we're both reading one of the same books right now, right?
Yeah.
That's The In Search of Certainty by Mark Burgess, right?
I wasn't sure if that would be on the list or if there was other stuff that...
Well, there's some of that from there, but then I think there's some other things. So there's a couple of things. There's a great book that the two of us are talking about, In Search of Certainty. And Mark Burgess wrote this application framework for monitoring servers. I forget the name of it. Do you remember? CF. What is it? CF. What is it? CF. CF, that's right, CF engine. Okay, right. So Mark has this idea about how to create things that can sort of have a little bit of independence on their own. So to him, message passing is incredibly important. Time factors and time scales are incredibly important. So there's some of that in that way I talked. Right. But there's some other things I think you probably saw in code about encapsulation or stuff like that, right? I tend to write very defensive code. Actually, although it's hard to see in like the summaries, but you might have seen in some of the detail, I write a lot of verbose code. I said, if this thing really exists, then go do something. All right? I don't say, go do something. I almost always say, if this really exists, even though I know it's supposed to be there, because you promised me it would be there. So I do some of that defensive coding. Is that some of what you're
that's what I'm talking about. Sure.
Yeah, I definitely do a lot of that, which means that my code is more verbose than most of my colleagues in a lot of cases. But it also means that my code breaks less often or breaks more gracefully. So if it turns out you forget to send me an important thing, my code just says, okay, then we'll move on. But most other people's code might.
All right, part 2, and I'll go.
Okay.
This is actually the bomb.
Oh, okay.
This is really broad.
Okay.
So the components versus connectors.
Yeah.
That's a great explanation of the territory, but it seems like that's shifting a lot. Like maybe it may shift slowly, but I can see there's more connectors. We get more and more connectors over time, right? And the components maybe have to adjust to that. So let's say some weird sci-fi dystopian future where there's artificial intelligence, machine learning that can just take all our data and figure out who we are. How does this structure or this impulse to create APIs fit in with a world that could just the AI itself figure that stuff out?
Well, so I really stink at this AI stuff. I'm going to be totally honest with you. So I'll give you just some sort of a general idea. I really think that we can. So I'm going to punt on this. So given the preface that I stink at AI.
What was a sci-fi novel anyway?
I'm going to tell you this, that it's not that the AI we think of is where machinery starts to understand meaning, and like it knows what you mean when you say stuff, like a Star Trek-y sort of thing. I think we can do so many cool things before that I've decided to not even try to figure out how to do that. Okay. So what I'm trying to figure out is how to keep things incredibly simple and keep the sort of the semantic or understanding thing almost zero. So my best model for that is one of the most complex and amazing message models that I've been ever exposed to. That's RNA and DNA. RNA and DNA, this incredibly amazing thing, and there is like zero semantic understanding in that crap. Split, go back together. Split, go back together. Whoops, drop one. Split, go back together. That's it. That's it. Now, it turns out there are some amazing ways to interpret that message. If you get into bioengineering, it turns out that the list of items in a row, like the list of G, C, A, T, and all that kind of stuff that we sort of know that we label as chromosome pairs, we can read them in a list and sort of get an idea of what's going on. But it turns out you can also read them in groups and get additional information. And it turns out you can read them in overlapping groups to get even more information. All of that is not in the message. It's in the code that reads the message.
You have a really good understanding of AI, actually.
But the AI is not in the message, right? It's not. It's just a message. It's a simple thing. So I think when we get things like, building management and motion sensors and all these other things, they're going to start working together in incredible ways. They're not going to know a thing about what the other one's doing. You think about swarms of bugs and birds and all that other kind of stuff. They don't know what each other's doing. They don't care. But it turns into an amazing thing. So from the AI perspective, I think, from the sort of machine perspective, I think we're going to start writing code that's dumber. We're going to be writing components that are smaller, and they're going to work as a group, and we're going to have this sort of resulting bit. But I haven't done any of that. so
Aren't you doing that with APIs?
What's that?
Aren't you doing that with APIs already?
I'm trying to, but these APIs are way, way smarter than anything, or way, way more, what do I want to say, less resilient than anything I just described. These are so much less resilient than an ant or an ant colony, right? So that's amazing to me. That's incredible to me. I could talk for hours about why is it that all this work I do, and I can't even actually be as smart as a bunch of ants, right? So I think there's something else there. Is that sort of close to it?
Yeah, well, that is, and I guess to maybe the idea that like you're saying, maybe APIs can get too sophisticated, and I think you and Forrest were talking about Brett Victor's talk, where it's about maybe microdata and these little discrete, or messages, little discrete ways of handling packets.
Yeah.
Can just be sorted however the machine feels best.
That sort of add up over time, right?
Yeah.
There's sort of a resulting behavior thing. There's a whole theory called cellular automata that talks a lot about this space. When I have a chance, I'd love to tell people about it sometime. I don't want to take time now, but there are some very, very curious things that have been around for 40 years, like Brett Victor talked about what we were thinking in the 50s and 60s, and isn't it amazing in the 70s when he did his talk. But there's lots of cool stuff in that space too. Yeah.
Got a question from Adele in Melbourne.
Oh, okay. He's reading it on his watch. I'm sorry. Go ahead, Dave.
Lucas jealous that you got these answers.
Yeah, I didn't get that same one.
Right. Love the idea of committing to no breaking changes, but doesn't that rely on the assumption that only proper Hyper-V clients are using the API?
So the short answer is yes, but the long answer is no. So here's why I would say that. So the short answer is yes. To get advantages of these no breaking changes, you need clients that are defensive, like the way I was writing. But no, in the sense that I'm never going to be able to control how people use my message, right? So I can be responsible to a point. That's why I sort of talked about the difference between server implementation and client implementation. So yes, there's definitely, let's see if I can do this. There's definitely some responsibility on both sides of the equation, but there's only so far I can go. And I still have, I put out a handful of hypermedia APIs, and see, imperative clients use that just fine. Right? They sort of memorize the path, they memorize the steps, they memorize the responses, and it works. So yeah, maybe if I rearrange those responses, that one might break. So hopefully that helps. See if there's a problem. Anything else at all? Anything? Yes?
I'm curious, this wasn't talked about too much, but I'm curious about security API. It seems like a lot of people really, really prefer OAuth. I've used OAuth before, that seems great. But Amazon doesn't use OAuth.
Yeah.
All of AWS, they use HMAC.
Yep.
And they're obviously a fairly big player in that space. So I'm just kind of curious what your thoughts are.
Personally, this is me. Personally, I prefer OAuth because I think OAuth gives us a lot more opportunity. I prefer OAuth because I don't trust any of you people. And I can have third parties, like I can actually have an application that uses Luke's like depends on Luke's users and you as a validator service, and I don't have to own any of that. And that's really what OAuth brings, which I think is really, really cool. It turns out we have dozens of formats, right? Dozens of authentication schemes, Kerberos and HMAC and SWAT, right? The token thing, the script tokens. What we talked about earlier today, and I did skip it here, is that I really think that security needs to be sort of a separation of concern from the rest of your code. Like security shouldn't be part of your API. Your API should be secured by something outside, right? And I work for a company, let's be blunt about it, I work for a company that sells security proxies, right? So we make money on this stuff. And what we do is we offer a proxy that lets you decide which security schemes you want to support for this API. Certificates, LDAP, OAuth, Kerberos, RSA key, boom, boom, you just check boxes and pay us lots of money and it's win, right? And it doesn't matter to your API. So I think security is really, really important. And I actually think we haven't even started to touch the possibilities for security schemes. There actually have been like 3 or 4 that are in flight right now with HTTP BIS, the new change before 2.0, and I think we'll see more of it. So I think if you treat it as a separate piece, it's really important. The other thing that I can tell you a lot of my customers do, I got a lot of enterprise customers, they use sort of SOAP-based, XACML, and other really wild, fruity kind of complex security schemes inside the enterprise. And they go to this proxy, and it gets switched over to OAuth on the outside. So a lot of times in a conversation, you're going to have 2 different schemes or multiple schemes in the stream. Right? Does that help? Does that give some ideas?
Wasn't the answer I was looking for.
Oh, I'm sorry. So I talked for a long time. What answer were you looking for? Like, what were you really thinking more?
I mean, I guess to me, like it seems like the big 2 really are OAuth and HMAC. So I guess you answered half of it, which is the advantage of OAuth is that you can then have more shareability.
Yeah.
To where you're one API since they have to own everything, OAuth allows that connection in a secure fashion.
Yeah.
Right? For something that's being more proprietary, when you're not worried about sharing things, is it really worth going through the whole OAuth dance when you're not going to reap any of those benefits? To me, HMAC seems like a very kind of elegant and simple solution that is incredibly secure.
It's pretty simple. I really get tired of combining all the headers and putting them in alphabetical order and all that kind of crap, right? Which is what HMAC does.
Well, that's why Amazon implements HMAC, you know, so they have to sign all the headers in that.
Right. OData does the same thing.
Right.
Azure does the same thing, right? So it's kind of a pattern. Honestly, from my standpoint, I kind of don't care. I want all of this to be easy. I'm really annoyed that OAuth is so fiddly.
Right.
It doesn't seem to be a reason to do. Do you know the site OAuth.io? Anybody use that? OAuth.io, and it's like easy, easy peasy. These guys actually did the brutal labor. I think they have 17 or 20 different ways to do OAuth, right? They worked through all of that pain. And they offer it as a service, and they also offer an open source version of their server. So that can make some of that cheaper. But there are more things. It's not just the actual fiddly bits of OAuth, right? But it's like who's the store, who's the provider, who's the validator, right? Stuff like that. So yeah, if you don't need it, I still use HTTPS, whatever is this? Basic auth over HTTPS a lot.
I think some of that is that some people say, well, we're never going to share our stuff today. But the nice thing about OAuth like 2.0 is you get the 3 different types. So you know, as soon as they want a mobile app for their internal employees, they now have a way to do that securely. So it's like, I think OAuth kind of thought through the different possible things we could do. And you can do like a simple, basic internal only without that kind of shared token stuff. You can just do the, hey, I got the name and password.
Just because you have HMAC on the end doesn't mean you can't have OAuth on the front.
Exactly right.
You have multiple layers.
Exactly right.
I don't think one is necessarily exclusive.
Exactly right.
That's what I'm starting to get. I think it's interesting to me that you say basic auth over HTTPS is fine.
For me,
from a security standpoint, I think that works.
Yeah.
If you're over HTTPS, no one's going to be able to look in and see that.
It's going to be tougher, yeah.
I mean, you couldn't in a public way support just getting post data directly from an HTML page because it would have to load up everything in DOM. That's the only real issue there, which is maybe not a concern in a lot of scenarios.
Yeah,
But
yeah.
then I do a lot of other reading online, and it seems like a lot of people feel like APIs should not be doing basic auth, that it's too simple, that there should be some kind of API way of having security protocol.
There is.
And those guys point towards OAuth.
Yeah.
There is, and it's not OAuth. It's just because the academic purist here. Back in the 80s, there was a great system called Athena, working under the MIT that really addressed a lot of these issues that have been carried forward. The True Answers client certificates really handles all of this and handles it in a clean, elegant way. There's just a lot of interest in the industry right now that's completely counter to actually doing client certificates. But it wraps up all these problems. And when we talk in terms of separation of concern and concern, the concern with security should be at the transport layer, and think about when we connect to servers. What do we use? We use HTTPS. Right. The server wants to know who we are, they can just use HTTPS. And it's that simple, and we go. But right now, we're having to play all these games, and so the short version is there's no good answer because we're unwilling to accept one good answer.
And actually, I should point out, HTTP 2.0 wants to use HTTPS all the time. In other words, they want to make TLS transparent. So you have that information. Some people think that's a great idea. There's a whole bunch of other people think it's a terrible idea because all of a sudden there's things I can't see anymore that I should be able to see. It's my right to see it. There's like a whole lot of...
Those are advertisers.
Well, they'll be advertisers, or they might be parents, or they might be, companies, right? There's all sorts of people who think they want to see that. So I think, there will always be companies like the one I'm currently working with where they make money off the fact that we can't decide. We just looked at this one, we'll do some of these, and we'll do client-side certificates, and we've tried a couple of client-side certificate things over and over again. Was Web ID, was that one of them that we tried as well? There was like, every couple of years it comes back. So it's not going away.
Is it similar to like just SSH keys, public and private key? I mean, would it be similar? A way to think of it?
It's like servers talking to each other, right?
No, it's exactly that. Like basically, let's say you want to pick what's your favorite OAuth provider? Google, Facebook,
Yeah.
Exactly. Yes, that's it. Facebook, right? What did you say?
Lovely fun.
Lovely Planet, yes.
Somebody in the room. Okay, good.
So let's say you wanted to, you became a long client user, you wanted to download travel information from another location. Basically, what we would do is we issue a client certificate to you, basically saying that this person, we validate through our certificate that this person is Luke and he's in our system in these different pieces. And then as soon as you hit their site, they just read and go, that's signed my local client, good to go, thank you very much.
They install that certificate into their browser, is that how that works?
Exactly.
Yeah.
If you have client certificates on your server sometime, you just hit it with your web browser. Almost every web browser supports it. Safari goes right back to your keychain. Apple's got an entire backend implementation that makes it really clean. Unfortunately, they won't let you install certificates for app usage, like via anything like that app directly. There's a keychain like block out there on the line. They made that design suite. But yeah, then you just basically say, yeah, this is my certificate, go. On the authentication side, in your server code, right, when that request comes in, you actually don't even have to make a request to validate that it is that person. It's just instantly there. There's no login process. It's the login process actually happens on the client in terms of picking who you want to be. It's like, oh, do I want to be Luke from Moment Planet, or do I want to be Luke from
Well, I think about like when I SSH into GitHub or something, or any kind of server that's using certificates or SSH keys. It's just, here's my public key. You've already got the, you got my public key. Here's my private key. We're all good. And you're just.
It's all and has it got allowed to two things. It's got consent and it's got federation. How do you those things that the certificate chain?
No, certificate chain actually does support that because when you sign the certificate chain, it's built extensibility, as we talked earlier, so you can actually sign an extension to say that we authorize, Lonely Planet could authorize Luke to do these particular privileges. They're just like URIs or URNs, basically represent certain levels of authentication. Those are wrote in the certificate. As soon as you hand us the certificate, if we have the Lonely Planet, mastered, or it's not private to the public, then we can check whether it was actually appropriately signed. Then there's actually no even outbound request from there. So it's even faster. You don't even have to hit the database to do a user lookup because you can basically extract information from the provided client certificate. It's faster, it's easier to use, it's phenomenal, but at the end of the day, you're not going to use Lonely Planet as your single source of being a user on the web. And there's a fair amount of infrastructure, there's a fair amount of interest in, because most of advertising the rest is demographic plays, et cetera, et cetera. Right now, the commercial interest is outside.
Yeah, did you guys, oh, I'm sorry. Go ahead.
Actually, it's not too difficult, especially Apple's done a fair amount of work to make that part probably simpler than trying to find somebody through OAuth chains or any of the rest of that kind of stuff.
You were going to ask a question.
In the talk, towards the beginning, you were talking about various diffuse message formats. And later on, you're talking about the content of the message and setting up the whole thing, these are the routes, here's the functions you're going to use,
Oh, so that the message itself would have the new URLs and the functionality. Yes.
Yeah.
Yes.
So I was wondering what the how important the format part of it is. The setting up the URLs, that made a lot of sense to me. But format part, is that closely tied together, or is the format part?
Well, what happens is if you don't agree with me on the object model first, then you have to have a really strong guarantee of something. So the message model and the structure of the message model becomes really, really important. So HTML is a message model, right? Or HAL or collection JSON or Siren or JSON API. These are very specific message models that will always have the same pieces in the same places. They'll always show a link the exact same way every time. They'll show arguments for links the same way every time. So that becomes really, really important. So then what happens is that client has to understand one of those. And the client and the server have to share that language. So that becomes a real important aspect to it. It's relatively easy for servers to add the representer pattern that would say, yeah, I can talk in JSON API or I can talk in collection JSON. It's actually kind of harder for clients right now to talk in multiple languages. So usually what happens is clients say, look, I talk in Siren. Anybody want to talk to me in Siren? Otherwise, I'll go somewhere else. Right? And then servers can respond. Does that make sense? Is that kind of the
I think so.
So they will all have their own rules about how they represent a template or a form. And then that client will always recognize that.
So I guess, what do you see as the more important partners to people? Having a standard format that everyone's going to know to look in these APIs for these certain things, or just the idea of communicating
messages to objects?
Well, I don't think they're unrelated, but in order to communicate messages instead of objects, we have to have agreed messages. So that means that eventually we're going to have to settle on these formats or a few of these formats. So we settled on HTML, JavaScript, CSS. It's sort of, and then a various set of PNG and GIF. Like those are the ones that actually make the web, right? It was a relatively small set. And I think we're going to need to do the same eventually for APIs. The idea of negotiating for a format is really good, and we have it built in, but it's a pretty high cost over a long period of time. I'm not going to write my watch or a sensor on the wall to talk 4 different formats. It's just no way. It's going to talk one. Right? I need to talk to a server that's smart enough to pull that off. So that is work that we have to do. In the last, since sort of HTML became really big, which would be in the 2000 era, 92 is when it was first version, or 97 was 3.2, right? I think 4 was somewhere around 2000. From that period on, for the first sort of 8 years, we had maybe 1 or 2 new media types added. In the 4 or 5 years, in the last 4 or 5 years, we've had close to a dozen new media types. So I think we're just starting that sort of round of learning, and we'll need lots more before we find one that really works. So the thing about, I quoted Darwin earlier. You know what really makes Darwin work? Death. Right? So there's lots and lots of versions of this thing. Most of them die. There's one that's left. So I think the ratio is we need a lot more death. It's kind of unpleasant, but death is the ultimate teacher, right? So I think we need a lot of formats, but we need to settle on 1 or 2. Something you can say.
Well, to your point about message over objects, and you just make the point if you're making this little widget on the wall that talks to something, it's going to talk one format, right?
Yeah.
So I'm trying to balance that with what's the importance of message over objects.
Because
Right?
this object on the wall, this thing on the wall is going to have one object model. That thing on the wall might have a different object model. Are they going to talk together? The one that senses heat, the one that senses motion, the one that senses light, the one that turns the fan on, they'll all have their own object models. But I can't have this one device learn everybody's object model. But we could all talk the same message on the outside, the same way we do. Like our own mental models are very different. Your mental model and mine is very different. We can talk. And I think that's the way we have to think about it. Because there's going to be billions, tens of billions of these crazy devices in the next 10 years. Some people are sort of selling on 50 billion. Somebody got excited and said 100 billion. Let's blur it out. But there's no way that they're all going to have their own object model. There's just no way. But they all can have the same message model, and TCP is a message model, right? TCP/IP is a message model. So we just need something a little bit higher than that. This notion of not just binary bits on a wire, but some kind of messaging structure like that protocols give us, like CoAP or MQTT or HTTP. We just need a little bit more. That's my thinking. Okay, it's getting kind of late. I kind of kept you a while. Are we good?
I'm still good. There's one question.
Yeah, I'll stay. There's no questions.
So when are we going to come up with the DNA message format? Just everything with the 4 letters.
Well, I would love this. I would love this because they can pull it off, right? Yeah, I would love it. I would love it. Actually, so in a really perverse sort of way, I mentioned Uber. Uber is an attempt to do something and keep it incredibly terse. But the problem with that particular format is nobody knows what the hell's going on because it's so terse, right? And that's a challenge. So that means I have to have tools if anybody's going to use it, right? We've got to have tools.
I hear the complaints with HAL. People like Simon because I think, how's the knowledge of what this piece of data you just gave me is, and I'm kind of like, but it's that good.
Right.
So it's just interesting that HAL is even more complex than something like that.
Yeah. I'm sorry, your name? Tim. So Tim kind of really hits on a really important thing. It's well, when is creating a new model for communication better than just using the object that you already have, right? And it really only pays off when you have a wide array of objects, right? If everybody's got the same object all the time, fine, right? So that's the thing, is when you have this really wide array of objects, suddenly it gets to be really, really complex. And that's really what happens. And I think this comes up a couple of times in this book about In Search of Certainty, is that the message isn't really the intelligent part. The intelligent part is the sender and the receiver. And if you try to put too much in the message about like what it means, you kind of cut things off. A good example would be the way our brains actually work. We sort of perceive things and then we interpret them in our heads. And the reason we know that works is why magic works. Because we perceive things and we have a model in our head that we match it to. That's why jokes work. Because we perceive things, we have a model we match it to. That's why illusions, like two faces or a vase or the old lady that's why those work. Because we kept a model in our head. That's the data. It's the same data everybody else has, but we apply a model. And it's not always the model that was sent, but it's a model that's used. And I think we need to build more applications like that, rather than have to agree first.
I think you came with a good idea for the next
All right. Build that stuff. Let me know. Call me.
Thanks again, Mike.
Thank you very much. I'll stay on.
All right, thanks for coming. If you have more